I'm starting up the stream. Looks like the stream is running. Hi everyone, I'm TigerHawk-T3, and today we are going to finish the deck that we started a while ago, and we had some trouble with slicing and slice assignment mostly. And this thing. This is very beautiful and tidy. This is slice assignment. It's very nice, but it doesn't work. So first couple things we're going to change. We're going to remove this because it's not going to be incomplete after this. And we're going to remove these things. And so I've been working offline to figure out what exactly was happening. First thing that was going wrong, that was making, we had our deck, and then we would assign to part of it, and then it would, you know, do the proper assignment, and then everything after the element, the last element from the assigned sequence was gone, was missing. And I was like, I don't know what's going on. But then I figured it out. You know what the problem is? It's these things that I didn't really test. But I did a couple days ago. And I figured out that they didn't do what I thought they would. Do you know why? These are two similar methods to insert a node after a given node or before a given node. Pretty simple. And what actually happens with them? Node quantity. Just want to make sure I have this. Here's my scratch copy. Remove and insert, I'm using those. Okay. So, just wanted to make sure I was updating the self.quantity properly, because that's important. But also important, here's our insert after and insert before. So it takes a node. It doesn't take a node. It takes a node that's in the deck that you give it, and a value that you would like to add into a new node after or before the node you passed. So we get a node, we get value, we say n is a new node out of this value, and then we say if the node that we passed has something after it, then we say this new node that we just made with the new value is pointed to by our node .next, and the old node .next, which is now over here, .prior. They both point to this node. Very nice, right? So do you see something missing? The new node doesn't point to anything. Oops. Oops. So what do we have here? This is basically my notes. We save a reference to the next one or the prior one, and then we assign that as before, and then we say the new node points to those things, the old node that we passed in and the one we saved. So why do I have a space after here? NXT, let's just call it other for consistency equals, and then we can just call it other in both methods. Other equals node.next, other. Node.next equals node.next to prior equals n. Yeah. Actually, no, because this puts the new node into node.next and node.next.prior here. N, we put n into our node.next and say this node has a next that points to n, and then we will look at this. Node.next, this is n now, not what used to be there. And then we say it's prior. So we have kind of half of a thing. We have a prior. So the new node ends up having a prior, but nothing next to it. And the old node that was after the past one has the same prior as it used to. Doesn't point to the new node. So this is all wrong. That's why we're fixing it. Because the way Python assignment chaining works, that's what this is called. Something equals whatever, is we start from the expression on the right, and then we assign that to each reference left to right. So first we'd assign n to node.next, and now node.next is n. So this would be n.prior equals n. That's very wrong. So we will call this other.prior. So now we have our node.next and other.prior both point to n in the middle. And we also have to say that n points to these things. N.prior and .next equals node and other. Right? Yeah, good. Same with this one. Next and last are the same thing, right? And then we also have to say this is, if there's something after this node, we have to say both point to the new one, etc., and the new one points to both. But if there's nothing after this, then we say, we can just append it, actually. Node.next equals self.last equals n, and n.prior is this. We can just append it. Actually, append is, might be reversed. So, no. Let's look for append, and append does, oh, we say it's self.last. Temp. Oh yeah, we're switching append and append left. Someone in chat says how to cook sweet potatoes. You chop them up and then maybe put some oil on them or something, I don't know. You get a cookie sheet and you cover it with aluminum foil, and then you put the slices of sweet potato on the aluminum foil and you bake it at some temperature for some duration. I don't know. Something like that. Maybe with, you know, seasoning, I don't know. Append and append left might be swapped. So we can't actually use this as a always at the end thing. So where were we? Here we are. N is now after the node we passed, and it is also the last one. And I didn't test reversal on that list. I can do that. H, G, F, E, D, C, D, A. D dot reverse. Now every time I have that, it will instead be something to reverse. Didn't think of that. I'll definitely want to test that. That's not what I wanted to do. I wanted to copy this, paste there. There we go. No. Okay. Still passes my test suite. So that's still correct. Whew. That could have been unfortunate. Unfortunate. Anyway, we say the node that used to be last now has a next, and the last pointer is our new node, and node.prior is or n.prior equals node. And then we do the same thing here. Other equals node.prior. If other, same problem here, n goes into node.prior, and then node.prior now points to something else than what we thought it did. So we use the reference we saved, and n.prior and .next equals, instead of before being the node and after being the other, we want to insert before. So we have the other one and then the node, right? Insert before. Insert before. Node.prior equals other dot next equals n. Prior and next is the prior and the node, so the other one and the node, okay? Otherwise, the node points back to something that is now first, which is n, and n.next equals node. Okay. This we could probably move into here, because we don't really need to save a new reference unnecessarily. If there's no node.prior, no real need to save it, right? Okay, those are repaired. That should be good. That's that part. Let me double check my diff of these things elsewhere. Okay, got that part, and the other thing I changed, other than testing, was the main whole bunch of stuff. Okay. What I ended up doing was realizing that Python list slicing works the way it does for very good reason, because anything else would be very difficult to manage and result in weird, undefined behaviors that I don't want to deal with any more than the Python actual developers did when they wrote that. Okay, so instead of this little thing, which is very tidy, we got the slice of elements in the deck, and we got the elements that we wanted to put in, and we went through both and replaced everything, and then everything we had left in the slice, because this would stop early whenever one of them was, if one of them was shorter, it would just stop, and we would have some left in the other generator. We say for everything left in the slice, remove it. Or if the element was longer that we passed in, add them. Easy peasy, right? No. One reason for that is because the exact way the zip function works is it will attempt to retrieve the next object from the first iterable that was passed, and then it will attempt to retrieve the next object from the next iterable it was passed, and so on. And as soon as it attempts to retrieve an element from an iterable and fails, it then ends the loop immediately and proceeds to whatever follows it. So, if slice was longer than the element that we passed, meaning something that would reduce the size of the deck, it would get an element from slice and be like, okay, I have this, and then it would attempt to get something from the element that we passed in, and it would fail. And it would be, okay, that's the end of the zip iteration. And then it would take that value that it retrieved from the slice and throw it away. Doesn't put it into node, doesn't do anything with it, it's just gone. So that was fun to find out. And it's a generator, you can't just, go back. So, and of course, if element was longer, then this works fine, because you attempt to retrieve another value from slice, and there isn't anything, so it's done. And so it never retrieves and throws away anything from the element. So that's lots of fun. And what I ended up doing to avoid that, because they could be lazy generators. They don't have a length. You don't know how many elements they have in that sequence. So what I did to solve that was they must have a length. And if they don't, exhaust the element that you're assigning from, which is exactly what the Python list slice functionality does that I didn't like. So there's a very good reason. Of course, their implementation is probably totally different, and they're doing this for consistency reasons somewhere, I don't know. But we're doing it because we need to know which one is longer, because we're turning them into iterators, lazy iterators, and we don't know which one is longer. So at some point we need to know which one basically should go first, because if this one is shorter, this works fine, but if that one is shorter, then it doesn't. So if we just swap these and have the shorter one always be first, so it never removes a value from an iterator and then throws it away, if that never happens, then we're good. So we would just switch these and switch these. which is what I did. Somewhere. Yeah, this is the set method now. It goes all the way down here. Yeah. Rather than this. This was very beautiful and very tidy, but no, it doesn't work. And from the Zen of Python, simple is better than complex. Complex is better than complicated, but practicality beats purity. If it doesn't work, it's not okay. And this didn't work. Didn't do what I wanted, so it's not okay. So first we have to check if it has a length, and if it doesn't, we will turn it into a tuple. This is so that we can see which item to have first when we zip. Here's that bit. If the length of one is more than or equal to the length of the other, then the other has to be first. Otherwise, we just swap it around. So, I don't know why I was asked how to cook sweet potatoes in chat about a Python stream. Writing a data structure. I really don't know. But I think it was, I didn't announce the user name, because it sounds like an advertisement. Go to such and such website. Yeah. But the chat content was weird and not actually spammy. I don't know. How to cook sweet potatoes. Today it's a cooking show. I will use the magic of copy-paste. So if there's no length, because we'll be using that, we will be using this. We will need it, and if it doesn't have one, then we're gonna turn it into a tuple, which does have a length. I used tuple and not anything else like a list or a deque, because tuples are slightly faster because they're immutable. Once you create one, Python knows that it will not be expected to change it in any way, so it doesn't have to make any allowances for that. So slightly better performance. I don't know. If you're worried about performance, you're not going to be using this module anyway, so it doesn't matter. But yeah, another option to consider and not use would be array.array. There's the array module, and it has an array class, and that is an actual typed array. And that's why I'm not using it, because it's typed, and many sequences and collections in Python are heterogeneous data types. You can have a string and an int and a float all in the same bag of stuff. So an array.array, it doesn't let you do that, so we're not going to use it. So we've got must have a length. We slice element. This is something we're going to change. It was weirding me out saying element for something that would be an iterable of some kind. So now we're going to make it plural. That's going to be elements. And that's the iterator that we're going to use. Next, we have a couple more things that we'll be using. First, we have, we're going to take the slice object that we got, and we're going to call its indices method, which gives us the exact indices that we will be using in our, for our collection. Pretty handy. it allows you to go from a slice with none or numbers outside the range of your data type's valid indices, and it will convert them. So if you have something of length 10 and you get a slice of like 20, 20, and none, it changes that to like 10, 10, 1 or something. Just gets the actual indices, and it changes negative values to positive. So just simple positive values within the length of your object. Very handy. And you do have to pass it the quantity, because it doesn't know the quantity, the length of whatever it is. So because remember, it's operating, it's a method of the slice you pass it, and it is not yet connected to the object which you are slicing. So you have to tell it how long the object is. We're going to save the start, and this is a 3-tuple with the start, stop, and step. So the first index, the last index, and the step between them. So we have the start. We don't need to save the stop, but we do need the step. And length is going to be important for length checking. We're going to take this 3-tuple and just use those as arguments for range. And so we unpack that with the star operator, send it to range, and range objects have a length, and we find it like this, and this is how long the slice is. Very convenient. So if step isn't 1, meaning if we have an extended slice, that's the term for any slice without with a step other than 1, like -1 or 3 or -20. And do I ever check otherwise what type it is? I don't think I do. Actually, I think, does indices take care of that? Indices take care of that. Okay, so if we pass like a string or something as one of the slice components, it will give an error from the slice method itself. Slice indices must be integers or none or have an index method. So that's fine. Leave the length. If we have an extended slice and the length, which is the length of the range object out of our slice, meaning the things we're assigning to, is different than the length of element, and this is the original thing, either something with a length or the tuple that we created out of it. If they have a different length than with the extended slice, it means we can't do that. And we will raise a value error just like the Python list would in such a situation. And I'm using the little trick of adjacent string literals can be placed together, just side by side, and they will automatically be concatenated. And of course, if you want to do that on multiple lines, you need parentheses for grouping, and we are already doing that because we're raising an error. And so we have this, and then we continue it with a format string for the length and the length of the element, and then we're done. But if this is not true, meaning either the step is 1 or it's something other than 1 but they're the same length, those will work. So we continue. This is where we handle this zip dilemma. If, remember, length refers to the slice of things we're assigning to. If this one's bigger, then we put it second. The larger one has to be last, so that it will try to take the next value from the first one and immediately fail and not touch the second one. Very important. Otherwise, just, switch the order. Pretty simple. So after we've done that, if the step isn't 1, meaning we have an extended slice, then that was it. We are done. Right. Actually, is this necessary? We know we have either one or the other. If we have an extended slice, then we don't want to do this stuff, only if it's 1. But if it isn't 1, and they're different lengths, then none of this will happen. No, we're checking if length. Elements won't have anything. Oh, yeah, we have, if there's stuff in there, then we'll be calling self.neighbors. Yeah, we want to avoid doing any of this if it isn't necessary. I think I'm going to be just copying and pasting this this block into the actual deck. So here we handle our zip problem, and then if we don't have if we have an extended slice, then at this point we return, because we're not going to be messing with other stuff that might change the length of the deck, adding remaining elements or deleting remaining elements, depending. It would be entirely taken care of by just this thing. But if the step is 1, then we can process the rest of the slice or elements. And so we'll want to, if the slice is longer, then we remove the remaining nodes in the slice, and then we're done. If length, meaning if there was something in the slice, then we want to go through the elements that we're adding and just keep, adding them, and node is still up here for node and whatever, or somewhere here. This is the last node that we worked with, and if length is to check whether there was a node that we worked with at all. Because if there wasn't anything in the slice, then node would never be assigned. That's bad. So this means if we got a valid node to work with, then, just keep adding stuff after this node, and that's your new node, and then you add after that node, and then you add after that node, etc. And that's how that part works. But if there wasn't anything in the slice, meaning the slice of the deck that already existed, then but if the deck was not empty, then we'll want to find which nodes to work with. We're going to call self.neighbors here to find what node we want to start with. And we have this node and the one before. If node, meaning if there's a node, it means that we're not just adding stuff to the end of the list. So if node is something we would get if we had a length of 10 and we're assigning to a slice of like 5, 5, none, or something. And then we would have a node and a node before it, etc. And then we do insert before, because we have our deque. And let's say we have, let's say node is the final element, and before is the one right before. And so if this is the one in question, then we want to insert all the remaining stuff that we're assigning before it. And then it will, you know, grow and push that out. And so it's going to try this once, just one more element, and it's going to put that before that node. And then after that, it will go through all the remaining elements and put them after this new node that we added. But if there's no node, meaning we have our deque and we're adding things over here, then the node after which we want to add stuff is the node before nothing, because there's no node, but there's a before, and before is what we want to add things onto. And then same thing, we add all the rest of the elements. And this else, if we didn't have anything in the slice and our quantity was 0, meaning there's nothing in the slice and there's nothing in the deque that we're adding, it was empty, and we're assigning stuff, then just extend the deque with those elements. I mean, that's all it's really doing, because there's no node to insert after and find. It's just, you know, add everything. I also could have done self plus equal elements, but that just calls extend, really. So this is more direct. And that solves that. I'm just gonna paste that in, because that's what I'm gonna do. From set all the way to delete. Boom. Lots of new stuff, but it's kind of necessary, because we don't want to have we don't want to be taking the next element from one of them and then find that the other was already done and then throw that thing away. And yeah, and we need a length to find out which one that is. So it's gonna behave the same as list slicing. And I believe after that, the only other change I had was in the testing, which was successful, and which I will simply show you. So I had the similar thing I was using before, a bunch of slice components to use in a row, and then this is checking the get portion, meaning like print D3:5. So I just want to get a certain slice. That's what this is testing. And then we test if then we test assignment. 8 is the same length as this thing, this stuff. So this is things that might bunch of values here, some of which are for extended slices. So they have to be the same length. This slice has to be just as big as this slice, and we're using the same slice components, so it's just going to be something of the same length. D has 8 elements, range 8 has 8 elements. So we're going to replace both of those, and this is for the delete with the del keyword. Delete if they're different, print something, and then we reset it and reverse it and reset the other one for further testing. And this is testing assignment that changes the length of the sequence. So they all have to have none or 1 for the step in the slice. And I'm adding 1, 2, 3 because whatever. And after each time I do that, checking whether there's still a match, I will reset with a backwards one and then reverse it to make sure that the reverse still works. This is non-standard, having an import statement in the middle of your file. And don't do that. The only reason I have it here is because I didn't want to forget it at the top. Because we really don't need any imports for the finished code. So I'm just going to have this here along with the thing that's using it. And then when it's done, we can just delete that, right? So looping 1,000 times, make a bunch of tests. We get a random integer between positive and negative 20. We get, 3 of them, and then we assign them to ABC. And we are, range 0 is empty, so basically deleting everything between A and B. So if it's A, B, C, D, E, F, G, H, and we have A and B being 1 and 3, then we would delete B and C. If they're not the same, etc., reset it. I think I had another test in here as well for a larger range, and that worked too. We're not actually using C. I think I used it for something else, but I wanted to test assignments that change the length of the sequence, and this works. Just by the way. See all the things of not printing? Yeah. See? And it's testing 1,000 random groupings. How about range 20? And each time I do this, it's testing 1,000 weird different possibilities, and it's probably something I could have with a normal loop to just test literally everything, but that's okay. 1,000 random ones is probably getting everything. Anyway, so that works perfectly. And nothing over here. Q. I think we can delete the stuff that we don't need. It's there. I'm going to let it end with the carriage return. Comments, perhaps? Maybe we can get one more stream out of this by adding doc strings to everything. That's going to be fun. I don't remember what half of these do. Yeah, I do. I do remember. But anyway, that's how you write a deck in Python. All done. Yay! Has all the functionality of collections.deque, plus a few other things. Append, pop left, clear, copy, count, extend left, index with start and stop. The other one has the to reverse. So here's one of the things that that the standard one doesn't have. O of 1 reversal. Because the usual way to reverse a collection like this is to go through the collection both directions, take the first and the last, and swap their elements, and go inward a bit, swap their elements, and so on and so forth, until you're at the halfway point, and then you can stop. This reverse does nothing other than tell the interpreter to look at the deck backwards. And so, if the deck is longer, it doesn't have to swap more elements. It just says, look at it backwards. If it has one element, it says, look at it backwards. If it has 80 million elements, it just looks at it backwards. So that's cool. Caused a lot of issues. Distance to index, norm index. These are helper things. One other thing it has that collections.deque does not have is slicing. Collections.deque doesn't have any kind of slicing, anything. Not get, not delete, and not set. The only Python object that I know of that has all of those is the list type. Strings and tuples have get, but they're immutable, so you can't delete or set. It wouldn't make much sense, right? So it has that. That's cool. It has insert. Insert is similar to append. If you want to add an object to the end, you use append. If you want to add an object to the middle after a certain element, you use insert. If you want to add several elements from a sequence to the end, you use extend. If you want to add several elements from a sequence to somewhere arbitrarily in the middle, you use slice assignment. So that's cool. And we can do that. Rotate, this is internal stuff. O of 1 reversal, slicing. Oh, the remove, I believe. Something in here was extra. I think it was the count. Let me look that up. Remove just takes a value in for the standard collections.deque, just removes a value that is equal to whatever you pass in. But this does that a certain number of times. By default, just one. I think you can do a negative number. What's the thing? Yeah. So this can remove and replace. These add. Oh yeah, there's no replace at all in the standard. So you can use it just like the normal collections.deque with remove, and it'll work as you expect. Or you can pass it a count argument, and it will replace, or it will remove that many of them, however many it finds, that you specify. Or if you have is there a remove all? Does it do all of them? Ah, yes. If not count, or we haven't reached it, you can pass a count of 0 to remove all of the values that match, or you can specify a particular count, like 5, and remove the first 5, or you can pass it a negative number to remove from the end. Isn't that cool? Same for replace. There's no collections.deque.replace. It doesn't exist. It exists for strings. You could have myString equals myString.replace A, B, and replace does have a count argument that you can pass to have it replace a certain quantity, I believe. And this one is the same count functionality as the remove. You can pass it, you can not pass an explicit count, and it will just do 1. You can pass an explicit number, and it will do that many. Negative count goes from the end of it backwards, and 0 does all of them, which is actually replace. By default, replace does all of them for strings. Should this count be 0? That's an interesting question. With return a copy of S with all occurrences of substring old replaced by new. If the optional argument count is given, only the first count occurrences are replaced. So the default is all of them. Let's change this. Strings don't just replace 1, and collections.deque doesn't have a replace. So let's make it match something that already exists and people might expect to use. 0. Now the default is to replace everything. And if you want a specific number, you can pass it count. And if you want it to start from the end and go backward, you make it negative. Great. Differences O of 1 replace, slicing, and enhanced remove and replace. Etc. and so forth. These are all very humdrum things that they should have in general. Node is a really small thingy, isn't it? I'm not super happy with this. It's a little difficult to manage. It's a long representation for just a node, but that's okay. Oh, there was something else I wanted to change because it was wrong. Where'd it go? Repro. The repro of a string is enclosed in quotes. I don't want that. And this can already do that. This is fine to hardcode that, because, I mean, if you change the name of the type, I don't think the the repro string changes. Let's check it out. We're going to import collections.deque. That's that. D equals. And that is okay. They have that. Not there anymore. Still says Deque. It's okay. We can totally do that. So this is fine. But the repro is not fine. Because first it's creating a string, and then it's getting the repro of the string. So it's going to say, well, we have this in quotes. And then we're going to be able to reproduce the string, not the Deque object. So we're just going to do that. It's the string. That's all. Because this is actually the way to create it again. And this also needs to change because we're not passing a bunch of explicit arguments. We pass it one iterable. Just like the standard collections.deque, because there's a reason they do these things. And the reason, as I found at one point, was it's much faster to pass in one object and then iterate over it than it is to pass in a whole bunch of references and then collect them into one sequence and iterate over that sequence. Performance reasons, basically. So today we fixed slicing. We changed replace to replace everything by default, and we fixed the string and repro methods. I'm going to write these down real quick. Slicing. To all. Fix string like that. Fix repro. Yes. So those are additional things that we have done here. Repro of an empty Deque. I just want to see. Good. I guess we could call it Deque, and then we would have Deque.deque. But EQ is fine. It's capital, which is a little more awkward to type with the shift, but it's also shorter. It's fine. It's good. I'm pleased with it. So we've made these changes. Everything works as expected. Nothing has any doc strings of any kind. Another Python stream we will do in the future is adding doc strings to all this stuff. Because maybe someone will want to use this one day. Do not use this. It's very slow. It is written in pure Python. It's going to be slow. Collections.deque is written in C. List is written in C. I've never needed to use collections.deque at all for, you know, real stuff. Just use a list. It's fine. Or, you know, some other built-in data type. It's all implemented in C. If you're using the standard reference implementation of CPython, which I highly recommend you do, because the others are garbage. Let me tell you. Oh my god. there's I don't know if I should mention the name. There's an online learning system that I have encountered. I'm a Python private tutor also, and sometimes my students are using this particular online curriculum, and the curriculum has everything built in, batteries included, sort of thing. You go to the site and it has assignments in a nice little list, and it has an explanation of what you have to do, and then a little text field where you're supposed to write your code, and then you can save it and run, and it has little test suites and everything. It's very great, except when it's wrong. And I do mean wrong. Like, it was explaining string formatting, which is very useful and it's very handy, and it was saying you get a literal curly brace in a format string by doubling that brace, which is correct. And then we went to do that, and it didn't work. Just didn't work. We wanted to format something with a variable specifier, and you can totally do that in Python. You can do cool things. Let's say you're not sure how large, or it was the precision that we wanted to do. So you can do this, and you get that. Great. What if you don't know whether you want 0.2 or 0.3 or what? You can do Isn't that neat? You can totally do that. So if you have this, format some number dot precision f instead of dot 2f or dot 3f, and then you have that. It's extremely handy. Note that you can only do this one extra level of nesting. You have your main thing that you're doing, and then one more. That's all. Plus, I think it was this that you can't do. Assuming you use the correct. What's its? What am I doing? It's one more level that it can't do. Ah, yes. Precision. Was it this that it can't do? I don't know. Point being, you can only have one extra nested level in a format string. So anyway, this course said that you get literals by doubling up the braces, which is true. And then we wanted to have a precision specified from a variable. And one way to do that is to create first one string with the format specifier, and then you use that format specifier again and add in your value, and then you have, you know, your result. Or you can just nest it. And anyway, we wanted to format the precision into our specifier string, and we wanted the resulting string to have curly braces, because then we would then use those in the next format call. So we doubled them up to get literal braces and say these aren't actual things we want to format, we just want to have a brace there, and it didn't work. And then we used the nested syntax to create a specifier, which we would then use later, and that worked when it definitely shouldn't have. Should have said not enough values or whatever. And I was showing the student in the actual official Python interpreter, and we're seeing different results because one of those is supposed to work and the other isn't. So to make a long story still pretty long, use CPython. It's really good, and it follows the spec properly, and it doesn't have any nonsense of, you know, use double braces for literals, and then it doesn't actually do that. People are free to implement Python all they want, but it's gonna be worse than the regular one. Same reason it's not good to write your own data structures and stuff, because it's probably gonna be not as good as more official ones, because staring at code for my custom data structure right now, because it's written in Python, it's slow. Whereas when you call collections.deque, it just does a whole bunch of stuff in C, and it's optimized really well and highly tested. Good stuff. So anyway, that's all there is to the Deque. We wrote it, we finished it. Only other Python, oh no, there was one more, 2 Python things to do in the future. One, write doc strings for these things, and next, I've been getting a lot of comments and feedback and questions about the point of sale system video, the Let's Code Python point of sale system, where we make a lemonade stand that sells lemonade and grapefruit juice and cookie. So I've been getting a lot of questions about that, and I thought maybe it would be good to do something more graphical with like Deque enter, and then we can pretend to have an interface. I mean, it won't be real. Instead of scanning actual barcodes, we're just gonna like click a button. It's gonna be our stand-in for, you know, this item was scanned. And maybe that'll be a more realistic experience, because usually when you go to a point of sale, you don't like enter the item in and then like write continue or whatever and enter a sentinel value to end the loop and that sort of stuff. It's not a console program that they use. It's just a input loop graphical where you just do whatever you want to do and it reacts, and when you're done you just say I'm done or whatever. Anyway, so that might be good to do. Other than that, I do not know. Doc strings, graphical point of sale, and then, I don't know, mini metro? I don't know. Anyway, I hope you enjoyed the stream, and I hope you enjoyed finishing writing the Python Deque. was pretty cool. It's been a long journey of 400 lines. Good gracious. And now that's complete. You may use it if you want, but again, I wouldn't recommend it because it's written in Python, while collections.deque is written in C. So, but it's usable, especially if you want to do a lot of reversal for some odd reason. I don't know. Thanks again for watching, and remember to like, comment, subscribe. If you're watching this as an archived video, I live stream on YouTube. If you are watching for the first time as a live stream, I archive my live streams on YouTube on this channel. And you can find lots more stuff there. Some of it is even good, maybe. I feel like we've gone on an amazing journey of writing this entire data structure. It's cool stuff. Okay, thanks for watching. Have a good one.